G'day, I'm Ricky Buchanan, and this is my whole world. I'm bedridden due to my disabilities, and I'm an enormous fan of assistive technology. AT lets me do just tons of things that I otherwise wouldn't be able to do. Just makes a lot of things easier and less painful to do. I'm going to talk about roughly the steps that I use to solve assistive technology problems. There's the same steps whether or not something custom is involved, but I'm also going to talk about a couple of custom pieces of assistive technology that I've designed. So this is a standard waterfall model. If you're a person who designs things or writes software, you're probably familiar with it. Firstly, we define the problem clearly, and then we brainstorm solutions to the problem. And then I do a cognitive prototype, which is something I'll talk about later, which is not a very standard thing. And then there's a physical prototype if needed, and then we deploy. And at any point, if any of those steps fail, we go back to the previous step or the one before and redo it and find another pathway, and hopefully you get to the end. And then you have a piece of functional, useful, customized assistive technology, and life is good. So I'm going to be talking about a bunch of pieces of assistive technology that I've made and how they came to be. And I picked them because each of them had a point that was difficult or interesting in a different stage of the process. So it lets me kind of illustrate the model and how it's all working. Things that I've invented for myself, which are including a 3D printed cup holder, the scaffolding in-bed leg splint that holds my legs in a good position, a drumstick that I use to adjust the position of my computer screen, and the mount for the computer screen itself, some wire baskets and phone holders, which are on my other bed, and also bilateral resting wrist splints, which I can put on and take off myself. And all of those are things that were not commercially available, or the ones that were commercially available weren't ones that I could use because of my specific requirements. So that's just a few of them. I've actually designed lots and lots of stuff, but it wouldn't all fit in the talk. So hopefully these ones will be good. Step one is define the problem. Sometimes the problems are fairly well described. At one point, my cups were all falling over and I couldn't reach them. So I needed to design a cup holder that would bring the cups within reach and stop them from falling over. Problems like that are pretty easy to deal with. And other problems that you have are kind of ill-defined, and it's difficult to figure out the edges, but it's really important to do that before you start trying to make assistive technology. For the wire basket and phone holder that's on my waterbed especially, the initial problem was something like, I want to reach everything at once and I can't help. Which is really not a problem that you can actually solve. It's too vague. So once I'd figured out that the problem really was that I needed some type of container that would hold things within reach, and also some type of mount that would hold my phone within reach, those are problems that can actually be solved. So then we could continue on, and we figured out how to solve the problem, and it was all good. So yes, make sure you define your problem clearly and you know what the edges of what you're trying to solve are. So step 2 in our model is to brainstorm solutions. So this is something that I usually do really slowly. I put the problem kind of on the back burner in my head and let it just kind of, I think about it in those odd moments when I'm not doing anything else. And because of my disability, I have to spend kind of hours every day lying on the bed resting. So I have lots of time to think about the problem. For example, with the computer screen moving drumstick, I was thinking I needed a stick to move my computer screen around, and I was thinking that I needed a stick which had something soft on the end because I didn't want to scratch up the computer screen. But I hadn't really figured out how to do that. I was thinking about how to attach soft stuff to a stick so that it wouldn't fall off. And then one day I was just lying in bed and I realized that there are drumsticks which are made and which are reasonably soft and attached to a stick. And I have no idea where the idea came from. I don't know why I thought it up. It was just kind of my brain cross-connecting ideas. I find that to get that, the time really helps. If you have time or you're not really having to find a solution right away, and you can just let it percolate, let it sit in your head and spin around. That really helps. It's one of the very few areas in life where being bedridden is an asset. So I really enjoy that part. For that problem, once I realised that I needed a drumstick, I was able to add some sugru onto the side so that the drumstick will stay neatly in my bed head, and it's always close when I need it. And so, yes, this is the result. It's very functional, and I use it probably 10 times every day. It's fantastic. So step 3 is the cognitive prototype. This is the step that I've added for myself, and it just basically means mentally testing the solutions that I've brainstormed. So luckily for me, I'm pretty great at visualizing things in my head and how they relate to other things. So when I've come up with something and I think it might be a solution, I just imagine how I'm going to be able to use that thing in all the different things that I plan to use the finished product for. So it's not foolproof. Sometimes you can imagine something working perfectly, but then when you get it made, it doesn't really do the job. It does help a lot for me to eliminate ideas that just aren't feasible at all. And the reason that I do this is that actual prototyping almost always requires that I have someone to help me. I need someone to build whatever the prototype is. And that usually is a slightly specialised skill. So it's usually something that my regular support workers aren't able to do, which means that either I need to call in a favour from one of my friends or my uncle who's an engineer, or I need to pay someone. And both of those are kind of limited resources. I can't be asking my friends and my uncle for favours every 5 minutes, and I can't afford to pay lots of people to make prototypes of assistive technology that might never actually work. So if I can eliminate ideas that aren't feasible before we make the prototype. The other thing that makes physical prototyping more difficult for me is being homebound, because when you're trying to describe to someone how to make things, it helps a lot if you can point to parts of it and gesture a lot and kind of just be right there beside them. And so if I'm instructing someone remotely to make a prototype for me, often I have to end up making really elaborate instructions for them. And these are the sewing diagrams that I came up with when I needed to ask someone to sew cushions for my leg scaffolding splint. It took me about a month just to do the sewing diagrams. And actually, I still don't have the finished product because the person who I paid to make it became busy, and so they're still making them. So I still don't know if all that work was worth it. So yes, if you can eliminate some of these steps by doing a kind of cognitive imagining of whether it's going to work, that really helps a lot. The mount for my computer screen is a really good example. There is literally no way to feasibly have the computer screen hanging over my bed unless I have the mount made. I can't really test whether the position is exactly correct. I can get a couple of people to hold it up there for 5 minutes, but I can't get them to hold it up there for several hours, so I can really test whether the positioning works for me. So at some point you have to just kind of cross your fingers and pay a lot of money and have someone make the final version for you. And luckily this has worked for me, and the computer screen mount turned out to be fantastic. It is a really high risk strategy, especially if, like most people with disabilities, you're existing on a disability pension and your disability equipment funding won't fund prototypes. I think until we have the sort of funding that lets you experiment and make reasonable mistakes, we can't really say that people have good choice and control. If the only option that you're allowed to make is the safest option, that's not really proper choice. The most frustrating time that I had trying to get a good physical prototype for something was with my wrist splints. I was working with an orthotist and I explained all my limitations to the orthotist, and I explained the way that I wanted her to make the splints, and it was reasonably different from the way that these splints are usually made. Bilateral resting splints are usually made for people who can't use their hands, so they're not usually designed so that you can put them on and take them off by yourself. But because I don't have support workers here during the night, I needed to be able to take them off so that I could go to the bathroom in the middle of the night. And I thought that I had done a really good job of explaining this to the orthotist. She was asking the right sort of questions that I thought indicated that she understood what I meant, and she agreed with what I said. And then the next time I went back and looked at what she'd created, it bore basically no resemblance to any of the special things that I'd asked her to do. The only conclusion that I was able to come up with was that she was so stuck in the groove of making splints the regular way that once I wasn't actually in front of her asking questions, she just kind of fell back into doing it the normal way. I did eventually end up with splints that were usable. They weren't exactly what I wanted, and they had sharp edges that I had to get people to sand, and they cost $600, and it was very frustrating. Luckily I was able to use them in the end, but yes, it's at some point you just have to cross your fingers and take the risk and get it done. So step 5 in our model is to deploy. So adjustments and repairs are almost always needed after deploying something. The first set of cushion covers that I made for the leg scaffolding were terrible. They kept falling off. The base of the computer screen mount also needed to be adjusted when I got a new bed because the old base didn't fit around the new bed. And also I often need to adjust things as my abilities decline, as my disability progresses. So it's not, you never really get to an end state where you're like, this is perfect, it will now work for the rest of time. You can just say this is now good enough to do what I need right now, and that's okay too. Designing your own assistive technology is something that I haven't really had a lot of choice over because my needs are so unusual and specific that they just weren't good commercial solutions in a lot of cases. But even for people who are better at fitting inside the boxes that assistive technology designers expect, I really do recommend that designing your own is a really awesome thing. You get exactly what you want. It ends up being the color you want, the shape you want. It suits your personality, and it does exactly what you want instead of just kind of being okay and solving the problem. It's really nice to have assistive technology that makes you feel excited to use it, and something that where you feel a lot of ownership and you can be like, hey, I made this thing, and then people will be stunned and amazed, and it's really nice feeling. We deserve better than just kind of okay assistive technology. For funding people, the thing I want them to know the most is that we need to fund assistive technology experiments that fail. This is something that, as far as I know, no Australian existing funding scheme has ever done. The NDIS talk a lot about wanting to support innovation, but in actual fact, they only support experiments that succeed. If you try something out and you have to spend some money trying it out, the NDIS really won't fund that. That means you can't really innovate a lot because you can't afford to have your experiments fail. Without the safety net, you have to play it quite safe, and you just go back to the tried and true solution because you know that at least that won't be a catastrophe, and that really stifles innovation. It's something where I really hope that the NDIS improves in the future. We need to make it safe to experiment with assistive technology and to have experiments that fail as well as experiments that succeed. Don't be afraid to try. Thank you.